Here all the points I have given. So Biot-Savart law is also a one inverse square law, like Coulomb's law, and inverse law of gravitation in gravitation, and follow the superposition law. Is inversely proportional to square of the distance. That means large range forces. These are fields forces. And similarly, so the field due to current carrying conductor is a vector, and field due to scalar quantity charge is also a vector. But the source for electric field is a scalar quantity. For source for a magnetic field is a vector quantity, that is equal to ideal element. So ideal element means we know current is scalar. So small element in the wire, anywhere in the wire, however the wire shape, it is independent on shape of the wire. So DL element, we will consider DL element. But field due to points and the length of the wire depends on the length of the wire. Means integral DL, not on the shape of the wire. This point also you have to remember. So now ideal is the vector quantity here. So ideal angle theta, and here Coulomb's law is depends on theta, but Biot-Savart law depends on theta. This is also one difference between these two, Biot-Savart law and Coulomb's law. So now what Biot-Savart law says, that means according to statement of Biot-Savart law, the field at any point from the current element or current carrying conductor, any side at anywhere, is proportional to ideal element, and it is inversely proportional to square of the distance, and is proportional to the sine theta. So from these three equations, I can write dB is equal to A into, here A is equal to, always remember, mu naught by 4 pi is A represents here. So dB is equal to A into ideal sine theta by r square. So this is the magnitude of field at point R from the ideal element. So the displacement R, where I want to find out the field from this element, is angle theta. So now dB is a vector. So in the vector form I will write. So AI into dl bar cross r bar. Dl bar, I is the vector scalar, so I will separate it. AI into dl bar cross r bar by r cube. So direction. So direction is perpendicular to either r bar or dl bar, or the plane containing dl and r bar. Like cross product, you know, direction of the cross product is always perpendicular to r or perpendicular to dl bar, or the plane containing dl and r bar, that equal to r bar. R cap I will take. So r cap represents it. So when here I am writing r cap means unit vector, you know, that equal to r bar. In the place of r cap I can write r bar by r, that equal to r cube will come. When I am writing dl bar cross r bar, so that will be r cube has to come here. So now dl bar cross r bar is equal to dl into r sin theta, we know. So r get cancelled. Therefore similarly dB is equal to a ideal sin theta by r square. This is the final formula for Biot-Savart law. This is going to use for all the cases. Means the field going to find out by circular coil, arc, different shape, means different lengths, bended form, circular loop, wherever, whatever. The magnetic field going to find by magnetic field of a one shape you are going to find out. So then this formula will apply. So therefore the magnitude of the field at any point from the current element is going to calculate by use this formula. Very, very important. So now first consider circular coil. Sorry, side conductor. First we will go side conductor. The field. So welcome back. So we study about the Biot-Savart law due to side conductor, means field due to side conductor. So here consider here, let this is the side conductor here given diagram, and theta is the angle between ideal element and r bar, position vector at point P. I want to find out the field, that is dB, in the distance d. Now here it is theta, means it is 90 minus theta, and the distance is equal to d square plus L square. So now for this diagram, the field, the B is equal to, I can write dB is equal to A into ideal sin theta by d square plus L square. So actually root over d square plus L square whole square has to come here. So directly I have taken. That is equal to. So now here in the place of, before going to that, so I want B. So that equal integral dB. I have to do. Now integration values are here, see. So this 90 minus theta is varies to, one side is alpha and other side is beta. So either alpha or beta. So this is angle here varying from alpha to beta. So this is beta and alpha. So now integration limit. So integral dB bar integral alpha to beta. So I dl sin theta by d square plus L square. So here you can ask me, sir, dl is there now, integral dl you can integrate now. So what, where to where I can integrate? So this is, I don't know how much length of finite. That's why I'm taking here angles I can integrate for finite length. The angle is from here to here, it is alpha, and here to here beta. So this theta is varying to alpha, beta one side and alpha another side. So I'm going to integrate theta. That's why I am converting this dl d into thetas. So for that, so here consider here in the diagram tan theta is equal to, that means tan of 90 minus, means here cut off 90 minus theta, tan theta is equal to L by D. So then L is equal to D tan theta. Or you can take cot theta, not a problem. So now this is equal to, here theta, here I have taken tan phi, I have taken. So this is phi. So tan phi is equal to, this is for easy purpose. So now dl is equal to d into d is not varies, secant square phi d phi. So now substitute here integral alpha to beta ai, a is outside and a is constant, ai mu naught by 4 pi ai dl, that means d secant square phi. Here theta is equal to 90 minus phi, substitute means 90, phi is equal to 90 minus phi is equal to 90 minus theta, or theta is equal to 90 minus phi. So I'll substitute here sin 90 minus phi is equal to cos phi into d phi by, so if you see here d square L square will become, so L is equal to d tan square d tan theta, that equal to L square equal to d square, means here d square plus d square into tan square theta. So that is equal to integral alpha to beta, so ai. So this is secant square theta, here 1 plus tan square theta if you take common. So secant square theta, secant square phi into cos phi d phi by, so d square into secant square phi will come. So secant square phi dd get cancelled. So here the remaining term is, so here the remaining is alpha to beta ai cos phi d phi by d. So that is equal to mu naught I by 4 pi d into cos phi d phi is equal to sin. So actually minus integral cos phi d phi is equal to sin phi d phi, sin phi. So that equal to, and here integration is, one is minus alpha, opposite, beta is upwards and minus alpha. Therefore sin of beta minus sin minus alpha. So that is equal to, therefore b is equal to, finally the b due to a finite length mu naught I by 4 pi d into sin alpha plus sin beta. So very important, b bar is equal to, or magnitude of b bar is equal to mu naught I by 4 pi d into sin of alpha plus beta. So here I can apply cases. Case 1 in Biot-Savart law. What is the case 1 means? So this is a field due to a finite current carrying wire, finite length of the wire. So here I can go infinite wire, infinite or long straight conductor, or long straight conductor. So for this, alpha become 90, similarly beta also become 90. So if you see the diagram clearly, if you see the clearly, so this is infinite. So suppose this is infinite, so then angles, so angles are extents, alpha is 90 and beta is 90. So now substitute the same thing in that equation, above equation. Therefore magnetic field due to infinite wire is equal to mu naught 2 into I by 4 pi d, or mu naught I by 2 pi d. So this is can be proved by Ampere's law also. So for straight wire, Ampere's law, for straight wire, long wire which is carrying current, so integral b dot dl, so is equal to mu naught into I. So here Ampere circuit you have to take, that is circular, so that will become b into 2 pi, r will be here d, is equal to mu naught I. So therefore b is equal to mu naught I by 2 pi d. From Ampere's law also we can prove it. So now coming into next case, case 2. So this point P, point on bisecting line, point on bisecting the line, bisecting the length, so such that equatorial line, right? So that means alpha is equal to beta will come. So in this case when they are bisecting means, so alpha will become beta. So I hope you understand this case. So in the case of bisecting, alpha is equal to beta. So that is equal to field from the general formula for finite length, mu naught I by 4 pi into 4 pi d into sin 2 sin alpha or sin beta. Sin alpha plus beta, sin alpha plus beta. From the diagram, bisecting line from the diagram. So this is alpha and this is the distance d. This is L by 2. If total length is L, L by 2. If total length is 2L, it is L. Then sin alpha is equal to here. Sin alpha is equal to. So for easy purpose, I will take total length is 2L. Total length is 2L. So then this will become L. Then L square plus D square will come, right? Sin alpha. So that is equal to B is equal to mu naught I. So here L is equal to total length is 2L, L is equal to length. If L is total length is equal to L by 2, you have to substitute. Then 4 pi d, mu naught I by 4 pi d. This you have to remember like a song. That equal to 2 into sin alpha, that equal to L by opposite side by root over L square plus D square, hypotenuse. So that equal to get cancelled, that is, so BD2 bisecting line, that is mu naught I into L by 2 pi d into L square plus D square root. So that means whole power 1 by 2. So this is the BD2 bisecting line on bisecting line of a current carrying conductor. And here mu naught I by 2 pi d is finite conductor, infinite conductor. Finite conductor means mu naught I by 4 pi d into sin alpha sin beta. So like this different cases. At one end of the straight conductor, so magnetic field to one end of the side conductor, so any one end. So that means, so case 3 check once, case 3 or case 4 this is. So field d to a infinite length wire, this is at one end due to this element. That means here infinite length means alpha become 90 and beta will become some angle, right? So for at one end, for due to the infinite run, one end, so there is alpha will be there, alpha will become 90 sin 90, so beta will be, otherwise one angle become 0. See this alpha become, so this is for infinite rod, alpha becomes 90, this alpha becomes 90 for infinite rod. So now beta will become 0, so there is no beta, so it will become 0, so it is along like this, right, parallel to this. So therefore B is equal to, in this case B is equal to same formula, mu naught I by 4 pi d into, so here only sin alpha, and here B is perpendicular to this line joining, so here this is, so sin alpha. Sin alpha means here this is not finite length, sin alpha only, alpha value and will give, that will follow, right? So alpha will become 90, sorry, alpha become 90, then that is equal to mu naught I by 4 pi d, so at one end. So this is one end. Beta become 0, alpha become 90, sin alpha only there, beta become 0, then sin alpha equal 90, substitute means we will get answer. If any other angle, then B we have to find out bx I cap plus b by j cap, other than finite length. For example, it's a finite length, not infinite length, it is a finite length. Then here B has two components, one is bx and b with this angle, right? So I have to find out bx and by. Here two components are there, db along x-axis and db along y-axis with the angle. So here db will become mu naught I by 4 pi d into sin alpha. So that alpha value is up to 45 along x and along y, we will find out. So this is related to straight conductor Biot-Savart Law. So if, for example, I want to find out the field along the current element, means R bar is parallel to, next case, this is current element ideal. So means case 4 along the current element. That means we know the cross product of ideal bar cross R bar is equal to 0 for parallel vectors. So therefore B is also 0. That means along the current element there is no field. So that is why field is inversely proportional to square of the distance. No, sorry, distance from the current carrying wire. So field is not inversely proportional to square of the distance. Field is inversely proportional to, due to the straight conductor, inversely proportional to the distance from the conductor, not square of the distance. So this is relations. This point also remember, not proportional to the square of the distance. It is inversely proportional to only d. So in Biot-Savart Law, we will study it is inversely proportional to 1 by r square. But when you are defining these fields and all, here it is inversely proportional to d only. D means the distance from current carrying wire. So when there is no DL element, ideal element, DL we are not considering, only IL we are considering. So then DL into R bar become R get cancelled, it will be D only present. That means R and D. In there I have taken R, here I am taking D. So I hope you understand this. I will come with solenoid or circular coil in the next video. So now we will discuss about field due to circular coil. So field due to circular coil and due to cases we will see. So same in the electric field also explain all these points. So similarly we will go. There also I have given, it is important to remember like this. And if you want to mean in explanations and some problems explain, here also problems applications I will take in another video. Only field, how to get the field and remembering the field formulas, and some applications are given, means directly you can apply these formulas. That's why. So now consider a circular coil here. So from the center of the circular coil in the distance x. So in the distance x, consider one point P from the center of the coil. So on the element on circle, consider one DL element. One DL element you consider. So current in the direction. So now DL element is tangential here, and this is the radius of circle R, and this is the distance between the DL element and the point. So this DL element, the angle between this DL element and this also one tangent. So here we will take this angle as 90. I'll tell here. So now this angle will become 90 here. So tangential direction. DL element and R bar are tangential. This is, so this distance is equal to root over x square plus r square. So here dB is like this, perpendicular to R bar. And now similarly extend this one. So here some angle phi you consider. So this also phi. So now this is 90 minus phi. So in the direction, so dB sin phi. So in above direction it is dB cos phi. So similar opposite element, symmetry element, if you take DL element, so due to this current, the fields are, vertical fields will be cancelled, and only dB sin phi I will integrate. So now if you take here field according to Biot-Savart Law, the field at any point in the distance d is equal to AIDL sin theta by r square, means here distance is equal to x square plus r square. So this is the distance between DL element to the point P where you have to find out. So now I am integrating here now dB sin phi I am integrating. So this The integration values here I will take dl value is 2 pi r. So that's why sin phi value also you can substitute here. So ai will come out integral sin phi is equal to, so here r by, so ideal sin phi by r by root over r square plus x square. So this is phi, sin this is theta, and here phi r square plus x square into r square plus x square. So dl sin theta. So as we discussed, angle between dl and sin theta is 90. So this will become that equal to ai into r by root over r square plus x square whole cube integral dl. Sin theta will become 1. So that implies b is equal to integral db sin phi is equal to total sum of the field, superposition of the field, that is b, is equal to ai into integral dl. Integrating dl is from total length, that is equal to 2 pi r by r square plus x square whole power 3 by 2. So from this here 2 pi r into 2 pi r square I can write pi r square is equal, that equal to 2 ai into pi r square I can write area of the, means that is s I can go, Sommerfeld area s, ais by r square plus x square whole power 3 by 2. So here for field, finally the field is equal to, the field due to circular coil is equal to, so mu naught by 4 pi r square x square whole power 3 by 2. Don't cancel the 4 pi, keep like that. So here I can write 2 into is. So that implies mu naught into 2m by 4 pi into r square plus x square whole power 3 by 2. Therefore the field due to ring at any point x from the center is equal to mu naught into 2m. Here m is equal to magnetic momentum. According to Sommerfeld, the magnetic momentum due to current carrying wires is NIA. So magnetic momentum is equal to NIA. N is number of coil, I is current, A is area of the cross section. So according to Sommerfeld, we write NIS, the magnetic momentum. So now if you see clearly this formula where x is very less than, very greater than r, means far point from the, very far from the axis, far from the center of circle, So x is very greater, then r will be neglected. So that's why the b will become mu naught by 4 pi 2m by r is neglected, x is very greater than, therefore x cube will come. So this is magnetic momentum, the field due to a bar magnet, short magnet on axial line. So this is the field due to bar magnet on axial line, b axial. That means for x is greater than r, the center of, means coil, circular coil, means circular coil behaves like a, behaves as small magnet or point to pole, small magnet I can tell. So next case where x is very less than r, that is equal to, x is equal to 0, suppose. So then b bar is equal to mu naught by 4 pi into 2m by r square. So 2m by r square. So this is at the center. So mu naught m by r square. Means this is the formula. B is equal to at the center. The center actually, center of the coil has to come mu naught. So here I can go with m also I'll change. Means in given formulas, remember in the magnetic moment, not in the magnetic momentum, in current I'll change this formula. So now see. So that is equal to B at the center is equal to mu naught into m is equal to is, I said. Is by these 2 pi get cancel, means 2 pi into r square. So this is r cube, sorry, this is r cube. Square root cube means r cube, this is r cube. So now s and pi r square get cancelled. S is equal to pi r square. So therefore mu naught pi by 2r. At the center of circular coil, magnetic field is equal to mu naught I by 2r. So whereas at far point mu naught 2m by 4 pi into x square. That also if you want to write in, so if you want to write in I caps, so b So here NIA, IA get cancelled here. So then finally the B is equal to V naught into, so here pi r square get cancelled, here R only will be there. So I by 2x at infinity distance means pi r square, means R square by x cube, mu into I into R square by 2x cube for long, at long distances due to current carrying wire of radius R, in terms of I and R, this formula. So in terms of M magnetic momentum, this is the formula. So I hope you understand this. So here magnetic momentum is equal to NIA against R2. So here only one coil means IA, if number of coil means NIA. So now for suppose the magnetic field induction on its axis at a distance x. So already we got that is this formula also. So I can write binomial expansion, right? This I am going to write in a binomial expansion with respect to center. This formula with respect to center I want to write, that equal to mu naught by 2 pi r. So in this, so take for example, so now see this formula required. So you know very clearly that is BD2 ring is equal to mu naught into IS 2 IS by 4 pi into R square plus x square whole power 3 by 2. So this I want to change in B axial and B center. So the relation between the magnetic field between B of axial and B of center. So this is B of axial, I know. B of axial means it is mu naught into 2m by 4 pi into x cube, B axial. So this is for suppose x distance, x is not infinity. So this I can change into mu naught into 2m by 4 pi into R square plus x square whole cube. I neglected the R square because x is very greater than R. So now this I am changing into B axial, I am changing into, see in this, and B center is equal to, B center, B at center is equal to mu naught I by 2R. That's enough. X equal 0 at center. So now I will change this into I items that equal to mu naught into IA, I into S, M is equal to IS by 2 pi. So R square if you take common here, so that equal to R cube will come out into 1 plus x square by R square whole power 3 by 2. So now whereas x is minimum comparable with R greater than R, then x square by R square less than 1 only will come. So that equal to here mu naught I by 2R I can write as, so pi R square, S and pi R square get cancelled. So this S and pi R square get cancelled, only 2R. So this I can write B axial is equal to, now B axial is equal to BC into 1 plus x square by R square whole power minus 3 by 2 I can write. Because it is x is some greater than R, not very greater than R, then x by R is automatically, x by R is greater than 1. Yes, x by R is greater than 1. That means, so here you cannot write this binomial expansion, you cannot write. So otherwise this I can write, the B at C is equal to BA into, I cannot expand this according to binomial theorem, it is not x by R is less than 1. If x by R less than 1 means this is 1 minus 3 by 2 into x by R whole square will come. So it is not like that. So BA into 1 plus x by R whole square whole power 3 by 2. So in terms of BC, relation between BC and BA, sometimes they will give x and R values and they will ask the ratio of BC by BA. So this is 1. Now whereas coming into arc, the magnetic field due to arc of length L. So this is arc and carrying the current I. So now it is making some angle at center. So that is theta, total is theta. So now consider one element. So one side of the symmetry, consider one small element here. So in electric field also same model, same thing will study. So this element is making some angle here. So now this is phi you consider, because integral of phi will be, integral of this phi will vary to minus theta by 2 plus theta by 2. Therefore the integration of phi is to minus theta by 2 to plus theta by 2. So this is integration. So now dB, you know dB is equal to I dl sin theta by R square. So here R is R, radius of this one R square. So now integral dB we are doing, and dB of, so here again cos phi will come, dB of cos phi. So and here theta, dl element and dr is always perpendicular in this circular coil. So this is a dl element and R bar is perpendicular. Therefore I into means AI mu naught by 4 pi, right? So AI into dl by R square. So here dl is equal to, means I am integrating now. So dl I can take here, the small element dl I can take, and here cos phi also there. So now here the d means here dl is the small element arc length of the small element ideal element. So dl is equal to r into d phi I can go, r into d phi. So that is equal to integral minus theta by 2 to theta by 2 ai by r square into dl. That means dl means r into d phi, r into d phi, r get cancelled. So therefore b is equal to, so a means mu naught by 4 pi, I also come out and r also come out here out. So integral, so here d phi only there, therefore d phi minus theta by 2 to theta. So that equal to b is equal to mu naught I by 4 pi r into, so here theta by 2 and theta is theta will come I theta. So this is answer. So theta is the angle between the angle of arc. Simple. Theta is angle of arc. This is the field due to arc. Field due to arc. So for arc is 4 pi means semicircle. So 180 pi will substitute. So due to means shape of the arc. So arc is like this. So with 90 degrees. So arc any shape like this with 90 degrees. Then the field due to this one is equal to cases now. Mu naught I. So pi by 2 is right. That equal to 8 r will come. Theta is equal to pi by 2, right? So theta plus pi by 2 if we substitute, pi get cancel theta. So semicircle at the center. The semicircle, and at this point, d to this point at the center. So that equal to b is equal to mu naught I by 4r. So you people can directly substitute combination of straight wire and semicircle and circles they will give. That applications I will give in the next class. So this is about field due to ring and arc. So the field due to ring is varies, means graphs also there. I have to explain that graphs. So it is going to much time. Solenoid also I will give in this video only. Maximum will understand. Try to understand. It will be long video. That is equal to field due to solenoid also. So whereas field due to solenoid, then solenoid is a one helical spring wounded on a with insulating wire wounded on a cylindrical bar or something. So now this is called solenoid. So each coil behaves like a bar magnet. Now current is entering like this. So solenoid depends on the end rule. Here end side. So current is moving this side end. If you see into the solenoid clockwise, so this will become south. According to phase rule of circular coil, so clockwise means the current is clockwise means south pole. According to phase rule, current is anti-clockwise in the coil means north pole. This is north pole. This phase. This is called phase rule. According to phase rule, you can find out the polarity of a coil, either it is south or north. So now in the coil, if you see in the coil, so the field is exist each coil, right, by the each coil, and inside this is uniform. Inside the solenoid, the field lines are uniform lines. Inside the solenoid, field lines are uniform lines, and at the end they are not straight lines. They are like bar magnet. That's why solenoid behaves like a bar magnet. We'll say solenoid behaves like a bar magnet because the field lines are same pattern like bar magnet. Inside they are uniform and outside they are non-uniform. So field lines are north to emanating at north and ending at south. So each coil behave like solenoid, and above this coil. So if you see, this is one coil like this carrying the current. So this side, if you apply the right hand thumb rule, so that and all we'll discuss in another class or sometime, because that much time not there. So here this and all out, and this is in, the representation of outfield and infield. So field one side is out and other side is in. One side is out and other side is in. So this is the solenoid structure. Means here the coil field like this. So now consider here one small element here, the dx element consider in this. So this is dx element. This dx element in the distance x from the one point d to magnetic axis in the distance r. So this is solenoid, axis of solenoid. From this it is in the distance r. So from r, so this dx element having the distance r. So this is angle phi. So similarly we'll go. This is due to coil. So now this one coil I will take as a straight conductor to explain this. So at this point in the x distance, dx element. So in this x distance there are n rings are there, n coils are there, consider like that, n coils. So the total number of coils are, the total n is equal to, total number of coils is equal to, in the consider length is equal to n into n in the place of n into dx second. So number of coils in the solenoid n into dx. So now this is the finite length of solenoid. Finite length of solenoid. So now similarly this pi is varying from one angle to another angle. So one end to another angle, that is beta. So this is outfield, here infield, coil. So now we know field due to the coil in the distance x, that equal to, that is V naught I into A, that means S, by 4 pi r square plus x square whole power 3 by 2. Here r and x, not to confuse, that's why I have taken r is the radius of coil and x is the distance from this coil. In the distance x, dx element I consider, dx element, that is ideal element in the x distance, like this. That is root over r square plus x square, distance, this distance. So this distance will become r square plus x square. So now here only one coil is there, so this is a formula. If there are n coils, means B is equal to V naught into NIS by 4 pi into r square plus x square whole power 3 by 2. So here n is equal to dx. So therefore B is equal to n dx in the n coil, that equal to V naught by 4 pi. So here n dx, I into S, area of the coil. So into dx, small n into dx by r square plus x square whole power 3 by 2. So now I am derivating this. So we have to derive, dx is there na. So this is the dB. Actually this is the dB formula. dB at a x element, right? dB formula this is V naught by n dx. So S value substitute here, everything, you will get B is equal to all the values 4 pi into I. So S is equal to pi here, and 2 is there, right? We forgot 2. So 2 also there here. This is the r 2. So that equal to 2 pi r square into I n dx by r square plus x square into whole power 3 by 2. Now again here see, from this tan phi is equal to, here will follow same like Biot-Savart law. Tan phi is equal to, from the diagram, tan phi is equal to x by r. Then r tan phi is equal to x. Then dx is equal to r into secant square phi d phi. So now this you are substituting here in this formula, r is secant square d square and everything. You will get finally the B is equal to, so now the finally r square 2 pi 2 get cancelled down, denominator 2 pi, otherwise keep like that, not a problem. The finally we will get, after substituting similarly like a long straight wire, we will get B is equal to V naught Ni by 2 pi 2 pi and 4 pi get cancelled, sin of alpha plus sin beta will come. So this is the formula for finite solenoid, the field due to finite length of solenoid. So now cases, infinite solenoid is there, that means alpha is equal to beta, that equal to pi by 2. So now substitute B is equal to, for infinite solenoid B is equal to, so here 2 will come, that equal to V naught Ni. So for infinite solenoid, the B magnetic induction to the infinite length of solenoid is V naught Ni. It can turn into circle, not to become toroid, that we will discuss in another case. So now in the case of solenoid of finite length and one end, at one end or midpoint you can consider. Next case is, it is finite length and midpoint. That means from the diagram alpha is equal to beta. So that is say some alpha or beta. So then B is equal to, you will get answer V naught Ni. So here alpha equal to beta means 2 sin alpha, that equal to V naught Ni into sin alpha. From the diagram, same like the straight conductors, same cases. But here only the difference is equal to, this is circular coil, there it is there, that is a straight line. So here sin alpha value from the diagram we can substitute. So this total 2L length means sin alpha will become from this diagram. So if you take diagram here like this is solenoid of coils. So this is the finite length and point at midpoint. So here I want to find out. So then alpha and betas are equal, and from this sin alpha is equal to, so this total length is L, means L, and R is the radius of the coil of solenoid. So then that is equal to root over L square plus R square. If it is only length, total length is L, this is 2L means L, total length is L. For suppose total length is equal to L. So then this is the midpoint. So here alpha is equal to beta, then this is L by 2. So sin alpha is equal to, in this case sin alpha is equal to L by 2 root over L square plus 4R square by 4, that is equal to 2 to get cancelled. This is sin alpha value. So you can substitute in the formula sin alpha. V naught ni L by root over L square plus 4R square. So similarly, one end. So if one end means one end of the solenoid, infinite length and solenoid. So see here, the length of the solenoid is infinity, and at one end, point is one end. That means alpha is become pi by 2, or beta become pi by 2, and beta is equal to 0. Alpha becomes 0 and beta equal to pi by 2. So like that. So now the formula B is equal to V naught ni by 2 only will come. 1 by 2 into V naught ni. Sin alpha is 90. So these are the cases. And this field due to the solenoid, the maximum. So at x equal to maximum at x is equal to minus plus or minus L by root 2. L by 2, not L by root 2, L by 2. Ring due to ring it is plus or minus R by root 2. The maximum field, magnetic field due to ring is equal to plus or minus R by root 2. Electric field also same. But a solenoid it is L by 2. So maximum at L by 2. If it is the long solenoid, infinite solenoid is turned into circle, means it will become toroid. So this is about the magnetic field induction due to straight conductor, circular coil wire, arc, and solenoid. So this is only there here. Magnetic field induction and force and motion of a charge, applications, and Ampere's law. I will make 5 to 6 videos. So maximum I will try to give everything. Applications I will go maximum on this current carrying field and force. In electric field I have given very less applications. In magnetic field I will give, and very important for advanced and means this concept. Thank you.